answer to this probability question is just the area of that. What's the width of this? 2. What's the height? 1/5. Right? What's 2 times 1/5?
1 over 25. No, wait, hold on.
2 times 1/5?
0.4.
0.4.
Yeah.
So 40% chance. Okay, maybe. That only works if it is uniformly distributed, at least to be that easy. Now, let me see. Yes?
So if the area was equal to 2, not 1, is that uniform also or not?
It could be uniform, but it's not a probability distribution. It's not a valid probability distribution. You see that? So I can give you a probability distribution. How do you make sure it's valid? The probabilities have to add it to 1, or they all have to be between 0 and 1.
Okay.
Are you with me?
Mm-hmm.
You guys remember? A little bit? Okay. All right. So, let's try another one real quick. Using the same, well, let's see. Let's do this. Using the same thing again. I'm going to redraw it. Let me ask you a couple questions. What's probably that it takes him less than 13 minutes? Do it the exact same way we just did it. So within that distribution, can you draw what that says? This probably takes him less than 10 minutes. Anything out here? Less than 10 minutes. It would be what probability? 0 chance, right? Officially, the way this is set up, it would be 0 chance for him to get there in less than 10 minutes. You with me? So less than 13 in the picture would be from 13 down to 10. Because past that, it doesn't exist. So this picture, what would this look like in the picture? Like that. What's the area of that?
0.6.
What's the width? I'm going to catch up to you guys.
The width is 3.
3.
And the height is 1.
And what's the height?
1/5.
1/5. 3/5. 0.6, 60%. Bless you. Kicks a lot of ass. Okay. What's the probability that it takes him exactly 11 minutes? This is going to trip you out a bit. This is going to trip you out. Oh, I didn't want to. Yeah, maybe. Remember, what's the answer to a probability question related to, in this case, when I can draw the picture? It's related to the area. What is the area of 11?
1.
No.
No, wait. 11.
I love you guys.
1/5.
This is going to freak you the shit out.
Yeah.
So, you ready?
Yeah.
You're like, I don't know, man. You keep saying it's going to freak me out. Let me draw it over again. Here's 11. Pop. What's the area of a line? I didn't say from 10 to 11, did I? It's not this. It's not this. It's that.
So 0.
Stop yelling, Jeff. All right. What's the area of a line? Is this tripping you out a little bit? I understand.
That's easier.
0.
How much width is there? There's none. So the width of that line is 0.
So 0.
So the area is 0. Now to be really, really, really honest, this is just in case you want to look this up. Officially it's 0. You with me? There's a nifty idea that I love to death. It's called iota. You guys know infinity, right?
Yeah.
What's one really like layman way to say infinity would be like the largest positive number. That's not a, don't yell at me any math people. Stop it. Because there is no largest positive number. You with me?
Yeah.
Because if you think you got it, add 1 to it. You didn't get it, haha. Double it, haha. Right? Raise it to itself power. Holy shit. You guys semi with me?
Yeah.
Is there any smallest positive number?
0.
0 is not positive.
Oh, smallest Point.
So it's sort of like what 0 plus kind of doesn't really mean, but still.
Point.
So this is called, just in case you're curious about it, you don't have to do this, it's called iota, I-O-T-A, iota. It's a nifty Greek letter again, but iota is the same as infinity, just reciprocated, and that's all I'll say. I don't want to freak people out too much, but just in case you're curious, you should look it up. But just remember this, when I ask you for a uniform curve, uniform probability, some x equaling something will be 0 because the answer is the area, and the area of a line is 0. Okay, maybe. And of course, I already asked one like this, but probably x is greater than 15.
0.
0, because outside of 15 ain't nothing. It all lives between 10 and 15. Okay, I like it. So, I really didn't want to keep you too long today. I'll tell you what. Let's do this real quick. 3 on the back side of this guy. Look at number 3. Can you just try to do part A real quick? This is roughly true. Even if I get a little key holder thing, I'm not going to remember to put it on there, so, like it's in my pants. Which pants? I don't know. So now it's between 1 and 12. It's just going to be a big ass rectangle. So when I say draw the distribution, I need to see the actual distribution. Anybody know what the height's going to be? Yeah, it's 11 wide, so it's got to be 1 over 11 to make it valid. That's the same thing as making the sum of the probabilities 1. And then you can answer any question I ask you, right? You just draw, I would redraw that. So the mistake people make is when I say 7 to 11, they'll draw a new one, 7 to 11, and change the height. No, this is the problem. That is the truth. That's the reality we live in. So 7 to 11, you've got to draw it inside of this thing. So here's 7, here's 11, and then you figure out the area of what you just drew. Some of you guys don't believe that it's that simple, maybe. So what will that probability be? What's the width of this?
4.
4 times 1/11, so 4 11ths, which is 363636. Is that right?
Yeah.
Cool. Divided by 11 and 9 is nifty. You get all this repetitive stuff. So you should get 4 for the width times 1/11, so 0.3636. All right. I think that's where I want to stop. I wanted to let you out early because I need to let myself out early because I got a 9 o'clock meeting I got to get ready for. But I'm just doing it for you guys. That's all. Aw, Jeff. Aw. All right.